This is a video presentation of Chapter 2, Section 8. This presentation is limited to the topic of decimals. If you're looking for the section on fractions or integers, please search for those videos on my YouTube channel. Okay, so what we're doing in this section is the exact same principles or concepts or rules behind solving equations that we've used in the past, except now we're going to apply them to decimals. Now there are some things that we can do in our lives to make these decimal questions a little bit easier, and we'll apply those concepts here. But for the first problem, I want to just work the problem as is before I show you how to make the problems a little bit easier, because you can always work all of these problems exactly as they appear without any consequence whatsoever. So if we take a look at the first question, it says a half x plus 8.7 is equal to 12.35. So let's go through and talk about our rules for a minute here. If you remember, we want to have our variables on the left, as in to the left of the equal sign, and we want to have our numbers all eventually somehow get shifted over to the right side of the equal sign. Remember, we can also flip the two sides around if we ever need to at any point in time. And whenever we want to move something to the opposite side of the equal sign, we do that by doing the opposite. So if we look at this question that's presented, we see x, my variable, is to the left of the equal sign. That's good. And we also have 12.35 to the right side of the equal sign. That's also very good. So the two things that are in the wrong spots are the 0.5 and the 8.7. Now remember, when you do a two-step, or if you simplify something and it's a multi-step equation, the thing that's directly connected to the variable will always move last. So this half, because it's attached to the x, is going to be the last thing I'm going to move in solving this question, which means the 8.7 is going to be the first thing I move. Well, since I'm moving it to the opposite side of the equal sign, I'm going to do the opposite. And notice 8.7 has a big old addition sign in front of it, so the opposite here is going to be to subtract. So I'm going to subtract 8.7 off both sides. Of course, on the left side there, that's just going to cancel out those two 8.7s, and on the right side, that's going to leave me 3.65. And as you can see now, all this really is, this is just a multiplication equation. Now it's just a basic one-step equation. Since we've already covered that, you should know exactly what to do. Since this is multiplication, I'm going to divide. I'm going to divide out half, or 0.5, on both sides. Of course, on the left side, the 0.5s will cancel each other out. By multiplying by 0.5 and then dividing by 0.5, that would undo each other as they're inverse operations. And the 3.65 divided by the 0.5 changes into 7.3. And that would be your final answer. Remember, you can always check this at any point you want to. Go back to your original equation, this first line where we highlighted. Change x into 7.3. Apply the order of operations on. When you do that, the left side should be the same thing as the right side. Okay, let's look at the question on the right there. This is a little bit different in that it's a division this time instead of multiplication, but all the same rules still apply. Z divided by 3.2 plus 7.42 equals 9.81. So I want variable z on the left side. It is on the left side of the equal sign. And I want 9.81 on the right side. And indeed, it is on the right side. So that's all good for us. But the 3.2 and the 7.42, those are not so good. So we'll look at moving both of those now. Remember, the thing that's connected to the variable goes last, or gets moved last. So 3.2 is the last thing I'm going to touch, so that means 7.42 is the first thing that's going to move here. Since that's got a big old addition sign in front of it, when I'm talking about opposite side doing the opposite, as I like to talk about, that means I'm going to have to subtract here. So I'm going to subtract 7.42 all the way across. And that'll leave me z over 3.2 on the left. Of course, the 7.42s have washed each other out, because if I add it and then subtract it, all I get left is what I had to begin with, which was the z over 3.2. And on the right side, I've got 9.81 minus 7.42, which is 2.39. Okay, at this point this is a division question now, so I'm going to solve this with multiplication. In this case, I would multiply both sides by 3.2. Remember, my end goal is to have this variable be the only thing on the left side. So since this is also a number, it's got to get kicked over here to the right side. And again, whenever I want to move something to the opposite side, I do the opposite. And the opposite is multiplying by 3.2. This divide by 3.2, multiply by 3.2 washes each other out on the left side. And on the right side, I've got 2.39 times 3.2, which is going to change into 7.648.